Hello everyone and welcome back to CodeChef. In this video, we are going to take a big step forward in SQL by understanding how multiple tables work together in a database. So far, you have learned how to work with a single table, but real-world databases never work that way. Applications like banking systems, e-commerce platforms, social media apps, and learning portals, all these rely on multiple related tables. In this video, we will cover different types of keys that are used to connect tables, how referential integrity is maintained, and important constants like cascade and set null. So let's get started. Keys in SQL. First, primary key. A primary key is a column, or it can be a combination of columns that uniquely identify each row in a table. Its key properties are: first, a primary key should always be unique. Then it cannot have any null value. We can only have one primary key per table, and it automatically enforces entity integrity. So primary key is one of the most important concepts when it comes to keys in SQL. Example. Now let's see how to set any column as a primary key. Create table students. So here create table is the syntax. Students is the table name. Bracket. Now what columns do we want in our table? Student ID. What kind of data student ID will store? Integer. So int. And then primary key, because we want to set this column student ID as primary key, comma, name varchar in bracket 50. So the other column name is name, and the kind of data that it will store is varchar, and that can have up to 50 characters. Then age, this is the third column, and the type of data that age will store is integer. So again int, bracket close and semicolon. So here student ID uniquely identifies each student, and that is why it is set to be the primary key of this table. Next is foreign key. A foreign key is a column in one table that references the primary key of another table. So like in the last example, we set student ID to be the primary key of table students. Now if I take that column as it is in another table, then for that table it will act as a foreign key, because actually it is the primary key of another table. Now what is the purpose of foreign key? First, it establishes a relationship between tables. Second, it maintains referential integrity. That means with the help of the foreign key, we can actually refer to the other table which has that column as its primary key. Example. Now in this example, we will see how do we set foreign keys. So create table, enrollments. Now here create table is syntax, enrollments is name of the table, bracket, then enroll ID int primary key. So for this particular table enrollments, enroll ID is the primary key, comma, student ID int, then comma, course name varchar in bracket 50, comma, and then foreign key in bracket student ID references students in bracket student ID, and then bracket close and semicolon. So we have already included student ID column in the table enrollments. But how do we get to know that this is the same student ID column which is acting as primary key for another table? By writing this particular line of syntax. Foreign key, then what is the foreign key? Student ID. And which table's primary key is it? So we will write references, then table name for which student ID is primary key, students, and then in bracket again we will write the column name student ID, bracket close, semicolon. So this ensures that student ID in table enrollments must already exist in table students. Next is unique key. A unique key ensures that all values in a column are different, but null values are allowed. So when we expect a column to have no repetition in its values or all unique values, but it can have null values, then that column can be set as unique key. Example, create table users, bracket, user ID int primary key, comma, email varchar, then in bracket 100 and unique. So because I am writing unique keyword here, that means all the values for the column email will be unique, but it can also have null values, bracket close and semicolon. Now let us see what is the difference between a primary key and a unique key. So first, are null values allowed? In case of primary key, no. A primary key can never have a null value. But in case of unique keys, the answer is yes. That means unique keys can have null values. Then number per table. So primary key 1. We can only have one primary key per table. But there can be multiple unique keys in a table. Referential action, cascade and set null. On delete cascade, when a parent row is deleted, all related rows in the child table are automatically deleted. So whenever we are making a foreign key in one table and from the main table in which it is actually acting as the primary key, one row is deleted, then that row will automatically be deleted from the other table in which it is acting as a foreign key. For example, foreign key in bracket student ID, references students in bracket student ID, on delete cascade semicolon. Now what is its use case? If a student is deleted, all their enrollment should also be removed. So as we know, student ID was the primary key of the table student, and we are setting it as foreign key in the table enrollments. So when a value of student ID column is deleted from students table, then it will automatically delete from the enrollments table as well. Let us go to the CodeChef platform and see an example for this concept. So here we have two tables. First, parent table, that is customers. So here we have data for 3 users, customer ID 1, 2 and 3, customer name John Doe, Jane Smith and David Lee, and their cities are mentioned. Then this is the second table, that is orders. In orders we have order ID, we have customer ID, order date and amount. Now see here, customer ID is the primary key for table customers, and in child table orders it is working as a foreign key. Now let's see what is the task for us. Write a delete query to delete John Doe's details from customers table and see changes in orders table. So let's suppose if I delete this entry, that is John Doe's entry from the table customer. So what impact will be seen on the child table, that is orders? Here for John Doe the customer ID is 1. So when we delete this, all the rows for customer ID 1 will be deleted. Let's go to the query. Delete from customers where customer name is equal to, in single inverted commas, John Doe and semicolon. And then we are going to print the second table, that is orders, because we want to see what is the change in the second table when we are deleting an entry from the first table, that is the parent table. So select star from orders semicolon. Let's run the query and see the output. So from table students we are left with only one entry, that is for order ID 102. On update cascade. So this concepts work exactly similar to on delete cascade. The only difference is that in case of on delete cascade, we are deleting a value from the parent table and it is then being removed from the child table. But in case of on update cascade, we are changing or updating a value in the parent table and that change is reflected in the child table. If the primary key value in the parent table changes, it automatically updates in the child table. Syntax on update cascade. Next is On delete set null. When a parent row is deleted, the foreign key in the child table is set to null. So in case of on delete cascade, when we are deleting a value from the parent table, it disappears from the child table as well. But in case of on delete set null, when a value is deleted from the parent table, then in the child table where that column is acting as a foreign key, that value is not deleted but it is just set to null. Its syntax is on delete set null. So here the relationship is removed but the child record remains. So the values are no longer there, but instead of those values we are having null in the child table. Let's go to the CodeChef platform and see an example of on delete set null. Here we have two tables. Parent table is customers and child table is orders. These are same tables that we saw in the last example. Now let's go to the task. Write a delete query to delete John Doe's details from customers table and notice the changes in the orders table. Coming to the query, delete from customers where customer name is equal to, in single inverted commas, John Doe, semicolon, then select star from orders. Let us run the query and see the output. So in the last example, entries with customer ID 1, that means for John Doe, were disappeared from the child table, that is orders. But here all the other entries are there, but just the value of the foreign key, that is customer ID, is set to be null. That brings us to the end of this in-depth lesson on multiple tables in SQL. Today you learned how do keys maintain structure and integrity, how tables stay connected using foreign keys, and how cascade and set null affect related data. These concepts are core to interviews, backend development, and real-world databases. Make sure you practice these queries on the CodeChef platform. Thank you so much for watching.